people will not be able to join.
Okay.
Yeah.
Hi, Dorcas. Hi, everyone.
Hi, Hanele. How are you?
All good, all good. How are you?
Very well, thank you. Hi, everyone. Welcome. We'll give it a couple of minutes before we start. Hello, everyone, and welcome. So we'll give it 2 more minutes and then we will start. Thank you for your patience.
Hi, Dorcas. Hi, everyone.
Hi, Michael. Welcome. Welcome, everyone. We'll give it, 1 more minute and then we will start. Thank you for joining. All right, I think we're 3 minutes into it. We're recording this meeting to share with the colleagues that are not able to join today. So I think we will start now, and I will start by introducing Christian Werner. Christian, maybe you should put your video on. And Lorena Batista. Some of you might have met them in some meetings and might have a one-to-one chat for some programs. But for those who might not have met them, Christian and Lorena, they are the quantitative geneticists that we have within the Accelerate work package. And they have been working most of the time behind the scenes to make sure that we have the methods, we have the tools and the systems on go so that we can be able to support the programs better. And today they're gonna introduce to us the new breeding scheme manager that we would be asking, and we are asking that the breeding teams register the breeding schemes in a central place that might help, that will help us to support the breeding teams better come early next year. So at this juncture, I will give the ground to Lorena, and Christian, please take it over. Thank you.
Right, I'm gonna start. So I'm Gonna share my screen for a quick presentation for introduction of the tool. Hope everybody can see that.
Yeah, we can see your screen, Lorena.
Yes.
Maybe, yeah, okay, good.
All right. So let's move forward. This is gonna be quick, just like a few slides for introducing the tool. We understand that plant breeding is a very complex and costly process, and it involves multiple production stages. And of course, many breeding programs will be comprised of these stages of crossing, early testing, late testing, and there's selection happening across these stages. And the breeders, they face the challenge of optimizing these steps when they have limited resources and time, and they need to release products for the farmers and competitive products for the farmers. So that's why these steps need to be optimized. And the goal of the breeding scheme manager is to help the breeders then document these steps on a breeding program and try to describe the essential ones. So like later optimization can take place because it's easier when you have a full figure of what your breeding program looks like. So basically, we intended the breeding scheme manager as a user-friendly online tool. It is designed to support the breeders if they need to discuss the pipeline with colleagues and or with funders, report breeding activities, look for areas that they need to optimize in their breeding programs. And also, if they need to introduce new technologies, it's much easier if you have a full picture of your pipeline of your breeding scheme as well. So like some of the key areas where the breeding scheme manager can help you is like estimating costs for breeding activities, such as marker-assisted selection or genomic selection. And also for us that provide support for your breeding programs, it allows us to gain insights into your breeding schemes. And when we see the full picture, it's easier for us to provide support as well. And the good thing here is like to make your life easier is that the breeding scheme manager is integrated with the market segments and the target product profiles in the PMC breeding portal. So for this rollout session, I'm gonna be like demonstrating, me and Christian actually, we're gonna be demonstrating how to fill out the breeding scheme manager with an example breeding scheme. We chose a line breeding scheme for this demonstration, but the breeding scheme manager provides, it offers specific spreadsheets for lines, for hybrids, clones, open pollinator varieties, and for synthetics as well. The example was created just to showcase the breeding scheme manager tool. It is not based on a real breeding scheme, so like line breeding programs like do not get worked up over this. This is just to showcase the tool. And yeah, so we will provide access to the following scheme, plus all the example spreadsheets, they will be already in the BSM. So it's good for guidance when you're starting off as well. And also the breeding scheme can be used maybe as a template because it's much easier to fill the breeding scheme manager spreadsheet once you already have an idea of what your breeding program looks like. So you can use this template, like example breeding program, as a way of documenting your own breeding schemes as well. So I'm going to start with the general outline of the breeding program. So we need to have an idea of what are the stages of selection. Here we have, as I mentioned, a line breeding program. It starts with the crossing block, and then there's screening happening between F1 and F3. Then the selected plants are planted in hedgerows in F4, multiplication in F5, Stage 1 yield trials in F6 and late stage yield trials in F8. The next thing we need to define, on this breeding program, is let's if we have a crossing block, then let's define this better. So we will we are assuming here that we have 15 parents with 20 crosses, and all parents coming from F6 within the pipeline. The mating design is random. So these are all details that are going to be captured in the breeding scheme manager. The next detail is the screening, is the number of individuals per stage of selection. So we have here that 200 individuals per cross equals 4,000 individuals, and subsequently for every step, like the number of individuals. Like we don't need to like nail down a very like specific number. So let's say in F2, like sometimes you have 1,800, sometimes you have more than 2,000. You have to choose a number that is representative of that stage. So here I chose 2,000 individuals in F2 because I feel this is representative of the number of individuals in that stage. And yeah, you can use like, I don't know, historical records to see how many individuals generally in each stage of selection. I know some crosses fail, but just think of a representative number of your overall pipeline. Also, it's important to differentiate between advancement and recycling. So here I know that in F6 I select both individuals to move on to late stage testing, and I select parents as well. So this needs to be clear when you're documenting your breeding scheme. Then you need to think about the traits that you're, sorry. Okay, it's just that. Then you need to think about the traits that you're going to be selecting for each stage when selection happens. So we see here for screening is used for plant height, maturity. Marker-assisted selection is stem growth and glutenin. Yield and a drought, falling number. Again, this is just for the example breeding program. I understand that there must be many, many more traits for actual breeders, but like we just keep in mind that you need to have all the traits that you select for each stage very clear when filling out the breeding scheme spreadsheet. And yes, if you're doing genotyping, for marker-assisted selection, for example, each trait, I specify the number of markers that I'm using for like doing marker-assisted selection. But if genotyping is happening for genomic selection, for instance, then you need to specify like what kind of density you're using and the number of markers that you're using as well. Also, what kind of selection value are you using? In the case of like visual scores, it's just visual screening. There's no like particular selection value other than your own eyes, like what your eyes observe. But then we have marker assisted selection. It could be a marker score. In the case of breeding programs that use genomic selection, as this example, I'm assuming that we're going to be doing both advancement and recycling using genomic estimated breeding values. And it's important to differentiate between sometimes like the advancement value is different from the recycling value. And also the selection method that you're using. So here it's just the acronym, but it's independent culling or desired gains index. One is used for recycling and the other one is used for advancement. So it's important to have in mind, like, if you're using, like, what kind of methodology you're using for selecting parents and what kind of methodology you're using for advancing as well. And yes, this example breeding scheme I'm showing here to demonstrate like all aspects that the BSM is going to be capturing. Feel free to use this as a template again to document your own breeding schemes. I understand that the species may vary, but the general idea of what kind of information is going to be captured is here. And I think it's much easier to have it schematized before, even if it's scribbling on a notepad by yourself. Doesn't have to be a fancy like PowerPoint, but just it's much easier if you think about your breeding program and you have it on paper or like on a document before you start filling out the breeding scheme spreadsheet. It's going to make your life much easier. And now I'm gonna switch over to Christian. I'm gonna be providing this link on the chat. So he can take over and start showing you the interface of the breeding scheme manager and the interface of the breeding scheme spreadsheet as well.
Thank you, Lorena. Hi, everyone. I have a constellation here with my notebook in front of the monitor, and it's a bit in the way when I try to talk about the manager. So I'm briefly putting on the camera to say hi to all of you, and now I'm switching it off again and move it and start sharing my screen so we can look into how to get started with the breeding scheme manager. You should be seeing my browser interface now. Let's start with the trivial stuff. This is going to be a very informal presentation, quick presentation of what this tool can do, how we can fill in the information that, well, you would like to document, you would like to share, what are the benefits. There are some videos in the making. Unfortunately, we've been waiting more than 6 weeks now for them to be edited, and they're still not there. There's going to be very nice formal videos. And again, this is going to be a bit informal. So let's start here. If you already have registered with the old tool, the breeding pipeline manager, your credentials should still be working, and you just put in your email address and your password, and you should be able to still log in. If you forgot your password, just click here, very obvious, and you can reset it. And if you have not signed up yet, well, you put in some information, your name, email address, institution, position, country, and so on, set a password and sign up. We are asking for this information here because you might know that this is supposed to be a CGIAR internal tool for the CGIAR breeding centers, for the NARS partners, not for externals from any kind of universities or something. So once you sign up, we all get an email. We look at it and check who applied for it, and we will probably give you permission within very short time, because as you know, we are spread around the world, so we are more or less working. One of us is working all the time. So within very short time, you should have your permission, log in, and see something like this here. So the first time you log in, you start with this very, very brief introduction panel here with basic information on the general design. So up here, there's some information. You can change your password. You can log out from the manager, or you can click on it, and then you will see the information that you put in during the sign up, and you can change it. Bit of an explanation of the individual, of the different buttons you have here to create a new breeding scheme, to refresh or reload, which is useful if you're working with someone simultaneously. You can toggle between only your schemes that you created, or you can see other ones. You can export that list, and you can call up this again with this help button here. You can see now it's empty. If I toggle here over to all schemes, I see all the schemes that so far, well, there's one from Sean, and the other ones that Lorena and I have created for demonstration purposes. I'm going to go back to only my schemes and add a new one. So again, this is just for demonstration purposes. So I'm going to choose wheat. If you choose a certain crop, you will only get the organizations that work on that crop. I'm going to choose ICARDA here. And the tool, the breeding scheme manager, is linked to the breeding portal. So you will get a list of all the pipelines now that you have added within your organization, within your breeding program. For now, we take a category 1 target product profile, which in the past was called a tier 1 profile. And the product type is, in our case, a line. And it's important you choose the right one here because, as Lorena said, there's different templates for different product types. This was one of the big issues with the former version that you might have used already. It tried to cover all different product types, crop types in one template. That was a bit confusing. Now each product type has an individual template. You can check again, create it, and then you see there is your pipeline with hopefully the right pipeline ID, the information you put it in, and some summary here that gives you also at the end of the breeding scheme name, a timestamp. It shows it was created on November 24. Now, I think this is all pretty self-explanatory, not too complicated. There's not a lot of buttons here. Now, when we have created our breeding scheme, we click on this button here and move to the actual template where we will provide all the information. Again, we have up here the name of the breeding scheme and the breeding pipeline. We have a couple of buttons here. You can show and hide columns, which is helpful if you want to work on something individually and want to remove all the other ones. We're not going to do that now. We can export into a CSV file the filled out spreadsheet that you then can, for example, load into Excel, again, to discuss it, to document it, to show it when it's not inside the tool here. There is an extra button for notes that you can make if you want to provide some details or write down something you want to remind yourself of that you cannot document here because, well, not documenting everything, it's documenting a lot, but there might be other things you would like to mention here. And here we just add a new stage. Now, there's different sections here that we will briefly go through and explain how to fill them out, what the kind of information is that we would like to have here. There's basics about the breeding population structure, the crossing and population structure, seed and material increase, genotyping, marker-assisted selection, phenotype screening, trial design, phenotyping, evaluation and selection, and advancement. So a couple of things that follow in, well, I would say the logical order of the procedure of a breeding program. Again, we're going to explain everything. If you forget what you're supposed to fill in there or what we mean, for example, by let's see, by phenotype screening, there's always explanations provided here when you hover over it with the mouse. So you can see this section, for example, is for traits which are selected based on a fast visual screening, mostly heritable, highly heritable traits, and so on. So there's always some explanations there as well. And I would say that with that, I stop here, and first Lorena, and then I will jump in again to give you a brief idea of how we would fill this breeding template with the information of the breeding scheme that Lorena just showed you in her PowerPoint.
All right, let me take over again now. I'm gonna be sharing my Chrome, maybe just my full screen, just so I don't keep looking for it. All right, hope everybody can see this now. And I'm gonna be starting on 4 sections. Let's hope it opens up. Yeah, all right. So first I'm gonna be exploring the breeding population section. This is where the main structure of the breeding program is mapped. Here, each stage of the product development process is going to be outlined. like what kind of generation of material that stage, like what is the generation of the material at each stage of selection, and like where is the which generation is derived from, breeding methods being used. Next, I'm going to be going to the crossing and population structure section. Here, the focus is on the composition of the breeding population, especially the crossing block. So this first part here is all for the crossing block. And then like you document the number of parents involved, the mating design, number of crosses. And as you progress through the generations, we switch to this side. It helps tracks like how the population changes across stages of selection in terms of like number of individuals and individuals per cross maintained in the breeding population. I'll then move ahead to the advancement section because it's easier after filling out the first two ones. Oh, I marked. No, it should be here. Where is it? All right, there's some blooper here is not showing. Jesus. All right, it's a tiny one. So the advancement section, where like this is a simple one, we're just like gonna track how much of individuals like you're advancing at each stage of selection. So like without further ado, let me start with the breeding population section. Again, I'm gonna be using that example breeding scheme here for filling this out. I think everything is going to be too crammed if I try to use both at the same time. So I'm going to hide this for now. And as I said again, I'm going to be sharing this and you'll be able to see the spreadsheets afterwards in the breeding scheme manager. So yeah, you can look and like how well I am matching the information on the PowerPoint and on the screen here. So we start with the empty spreadsheet. Yes, since we're following a category 1 breeding scheme, we begin with the crossing block. And in the product development stage column here, we're going to be selecting crossing and screening. And again, this is the very beginning of the breeding timeline. So we select year 1, season 1. Stage name is basically any custom stage name that you might have on your own personal records of your breeding scheme. So I'm just going to write here crossing block. The activity.
Sorry, I can't help you.
The activity here is crossing. And yes, for generation, like we choose the parents. And is derived from F6 within the pipeline. We're going to be specifying this better on the next section. And for now, we're just like, we're just performing crosses. So no breeding method is currently being used. Then we can add a new role and start with the second stage. Okay, let's use here. This is also crossing and screening because we're just like on the F1 stage now and we're not doing any late stage testing or anything like that. And year 1, season 2, stage name now, like I'm just gonna choose like, but yeah, you can choose a custom one. I'm gonna put here F1. The activity here, since this is a line breeding scheme and the parents are homozygous and there's no segregation happening yet, we're just basically increasing seed to get the F2 generation where the seed is sufficient like for start screening. So I was like, we're gonna select here, increase the generation is F1 and is derived from the parents. Again, no breeding method being used here yet. And yes, I'm gonna jump ahead and show you the fully filled section, which is the second spreadsheet over here. and we see how this looks like until the F6 generation. That's the stage that we filled up until now. And yeah, that's basically, you can see that there are 2 seasons per year, and we move through the generations over here, the different activities that are performed at each stage, the generation that they are derived from, and some information on the breeding methods. Again, the breeding method, like you can either work with the pre-selected options here, or you can write a custom breeding method. It doesn't matter. So you can write your own as well. And now moving forward, I'm going to go back to the empty spreadsheet to fill out the crossing and population structure section, which we have here. Basically, again, as I explained, you describe the composition of the breeding population at each stage. We start with the crossing block in the first row, and then the number of parents indicate where the parents in your crossing block are coming from. In our example, the crossing block has 15 parents, and they are all coming from the F6 generation within the pipeline. Yes. For the mating design, so we have just like these 15, we chose kind of a boring example, but your breeding programs might use from these other sources. So it can come from another CGIAR pipeline, a non-CGIAR pipeline, old breeding material varieties, land races, trait delivery and discovery. But in our case, it's just the 15 recycled within the pipeline. We select now the mating design. In our example is just random, and we're gonna be using 20 crosses for this example as well. And the total number of genotypes column is calculated in this, but it's not relevant for this for the crossing block. But then later generations like F1, you're gonna be like, if it's not a crossing block, you're gonna be filling out these columns as well. And for example, we will assume just one individual per cross, and we assume that all 20 crosses in the F1 generation were successful. And as I mentioned, like the total number of genotypes column is calculated automatically. And moving forward to show you the fully filled spreadsheet as well. Here we follow more or less like how the material is, like the breeding population is evolving over time. So in F2, we have 200 individuals and 20 crosses are still maintained, so we have 4,000. And then we start making selection within crosses, so all the 20 crosses are maintained. This is, we now have to cover this case where you don't track the crosses anymore. You start performing selection within and between crosses. Maybe you don't know how many crosses are kept on the population, you just know the number of individuals. Then you can fill this column instead, the number of individuals one. When you stop tracking the number of crosses and individuals per cross in your breeding population, then you can just use the number of individuals column instead. And the next section I'm going to be covering is the advancement one. This is a quick one. I have spreadsheets like pre-prepared for that's why I keep changing for every section. So the advancement section here is filled up until the F5 stage. So I'm just going to be filling the F6 stage for this one. So we look into the number of units that are advanced in each stage, and the percentage of units advanced is automatically calculated for you. These numbers follow very closely the previous section that I just showed, crossing population structure. So it's going to be easy to fill this one as well. Basically in F6, I'm also like the unit of advanced is a line actually, and I am advancing 100. This is just for demonstration. Then the percentage of units advanced is automatically calculated. And the next section I'm going to be covering, this is concluded. The advancement section is the seed and material increase section. It's on the third spreadsheet that I'm supposed to be using. And I have a field up until the F1 stage where individual was increased from the F1 generation to the F2, and the next generation where we have like a multiplication of seed step is the F5 one, where genotyping increase and advancement. So we have some increase here. I'm going to be filling this out. The multiplication, the experimental unit multiplied, like we planted in the field as a row to be multiplying. You can put units of length and width, and let's say we just used a single experimental unit to multiply. And that concludes like the 4 sections that I was going to be demonstrating. Christian is going to move forward with the other ones. Genotyping, marker-assisted selection, screening, trial design, and phenotype evaluation and selection.
All right. So given the time, I'm gonna keep the examples brief here. I think it has become clear already that it all follows the same concept. It's questions which are not new to you. It's questions which are related to what you're doing during your entire breeding process. And the same holds for these 3 sections: genotyping, markers, selection, phenotype screening, that we will look into now. So I told you we can, if we want, untick the sections that Lorena has already explained, just to get them out of the way for filling. And we can continue with the 3 sections. So you see all of them have these plus icons to add something. If there's something to add, if we want to add a genotyping activity in our breeding program, we first choose a technology, and I will start with a low density SNP assay, which basically means here a few, a few markers for major genes with strong effects that we will use during marker-assisted selection. We will add that. I can add another genotyping technology. Let's assume we also use a high-density SNP array at some point. And we can additionally to adding these technologies, we can have different applications. So you might, I don't know, let's say here we have something like 10 markers, and we use some of these markers for marker-assisted selection, but we also use these markers for something like QC, identity verification. It's all happening at this, what is some stage, it's probably F3 here. We also can, for the array, add genomic selection, and we say we have 3,000 markers, and we do this at what then should be F4 here. So again, all the different kind of technologies, all the genotyping associated activities you can add here. You add the number of markers, and we already get an overview here what's happening in the next couple of columns that we're filling out. We have indicated here that we're using, well, 10, maybe some of these markers for markers selection, and this is what we're doing here now. We can select a trait, and these traits, again, are, trait selection. The catalog is connected to the breeding portal where they are coming from your pipeline. On the breeding portal, there's something going on with this cold tolerance C here. But everything else looks good, and we're just going to use, I don't know, let's use, if you're looking for something specific, you can put it here, and we're going to use leaf rust. We now have leaf rust here as a trait. And again, in the same way, we can add more traits. And for these traits, we can add the number of markers. And in that case, let's assume we have 3 markers for leaf rust. After we have genotyped our material, we have done some marker selection. We might have this phenotype screening activity. And again, we have to do this, and we have to select all the individual traits where this is happening. So I explained a bit earlier that the phenotype screening section refers to these kind of traits which are quickly visually evaluated, which are very early in the process, in the breeding process, are culled in huge populations. It could be something like plant height, where you go through the field and have a quick look and remove individuals which are obviously too low or too high. So again, we use something like plant height here. And then we get a couple of extra columns where we need to provide some information, the condition. Again, like everywhere, you can add your custom information if your option is not there. We just assume now in the field, we're looking at, I don't know, we're looking at rows. There's a length of 5 meters and a width of, I don't know, 0.4 meters. And we're doing that in one location, and we have 1 replicate per location. And again, if you have if it happens in more stages, you just add it, for example, in the next stage again. If it happens with more traits, you just add another trait here. We're not documenting a lot of information for these, phenotype screening for these quickly screened traits, but we're selecting a couple of more details for the traits which we collect data on and which are afterwards, probably statistically analyzed to combine data maybe from different years, from different stages, from different locations, and to make a very informed decision here rather than a quick screening. Now in the trial design, we have these 3 sections: experimental unit, layout, and check strategy. And again, I think I'm going to be quick here because most of it is relatively obvious. I think I'm going to choose again field here, type of experimental unit. We might have moved to a plot now, and this plot has something like, I don't know, 5 meter length and 4 meter width. We can choose an experimental design, but again, you can put your own custom design in here. And then we collect some basic information on the entire overall field trial design that you're applying, that you're implementing in a certain stage. So let's assume we're testing at, making something up, 5 locations. We have 2 replications per location. We get, already based on the numbers that Lorena provided, the number of locations and replications. We get the entire number of experimental units per location and the total number of experimental units, which in this case, again, are plots. And we provide some information or the checks. With many of you, we had already extensive discussions about check strategies, to have spatial checks, potentially to connect different locations, to have temporal checks, to connect years, especially important when it comes to measuring genetic gain. So let's assume we have 2 of both, and we have check units per location. Then the you can see here the percentage of checks used per location, and then you can define what they're used for. Are they spatial checks? Yes, temporal checks. Maybe there's a GRM used to connect trials. Maybe there's entries replicated and so on. That everything you can document here how your trials are connected. And again, you do this for all the different stages where you have field trials or any kind of more sophisticated trials than just for some quick screening to collect data and have a statistical analysis to make your selections. And this is where we go now, the phenotyping, evaluation, and selection section. So this is probably the most cumbersome section for you to fill out, because optimally we want to have information on all the different traits that are in your target product profile, where you collect data on at all the different stages and get information on how your selection process for parent selection and for advancement decision works. Again, here on the breeding portal, the traits are allocated into these different categories of quality traits, agronomic traits, morphological traits, and so on. And you can add them as usual here, select a trait. Well, if you are not entirely sure if the trait you're looking at is a quality trait or some other kind of trait, you see in the catalog here, it again says what kind of trait it is. I'm just going to choose drought tolerance here now to edit. And because, again, this is a bit cumbersome to fill, I'm going to move now to another sheet where it already has been filled. So this is falling number here. And for all the different traits, again, at all the stages where they are collected, where data on these traits is collected in field trials, there's a couple of things we need to document here. This is these 7 columns that you see with these abbreviations at the last row. We collect information on the number of test locations per trait, phenotype evaluation unit, method of statistical evaluation, advancement value and advancement selection method, and recycle value and recycle selection method. So what does that mean? Number of test locations, I think, is obvious. You might have defined in your trial design that you're testing in 5 locations, but there's a trait like falling number, which is only tested maybe on material that comes from a single location. So this is why we again ask in how many locations this trait has been evaluated, or from how many locations the data comes. Now the phenotype or evaluation unit is a bit of a tricky term. I think in your specific program, it's obvious what you're asking here for. The genetic make, the genetic entity, we can look at the list here and it becomes quite obvious what we're asking for. So are you working with clones? Are you working with DH lines? Are you working with hybrids that you are evaluating and selecting on here? So in our wheat breeding program, obviously it's a line, and we use here these abbreviations because you see some of these columns are already quite broad. There's already a lot of space taken up by the information we need. And if we now, for all the single sub-columns of each trait column, would put the entire value in it, it becomes quite big. So we use these abbreviations. Now, the third column, method of statistical evaluation. That basically is what is the value that you calculate or the value that you get from your statistical analysis. Again, you could use just an average, which we don't recommend, but you might do that. It could be a BLEU, it could be a breeding value, a genomic estimated breeding value, genomic estimated GCA, and so on. Sorry, I was one too fast. Again, we're looking at the phenotype evaluation unit. What I explained was right, but we're first, again, defining if it is a BLEU, a BLUP, an average, a genomic BLUP, single record, pedigree BLUP. You saw already the other options, and you see there's some kind of overlap because you could use a BLUP, but there's different versions of the BLUP that you use for advancement decisions and parent selection, for example. So we take a BLUP here. No, actually, we take a genomic BLUP, and in the case of lines, it's easy because we're eventually interested in the genomic estimated breeding value to make our advancement, our parent selection decisions, and we use the advancement decisions, and we use independent culling here for the advancement. And for parents, we also use a genomic estimated breeding value, and we advance our parents based on a desired gains index. Now, if you work, for example, with, let's say, hybrids, you might, for advancement of individuals, you might be interested in, well, the, where are we? For advancement decisions, the genomic value, the total genomic value, while for selection of new parents, you would look at the genomic estimated GCA. So again, please be aware of what kind of type of plant, of crop you're working with, because this can be a bit tricky to figure out what is a statistical method and which of these predictors is eventually used for parent selection and selection of advancement candidates. And with this, I'm finishing with the word that if anything of this is confusing, and again, this might be the most confusing section, don't just put anything in. We're there to help. We're available, via email. Just drop us a message. And if you're unsure, just drop us an email, give us a call or something, and we can discuss what should be put in there. And usually it's something that can be very, very quickly figured out in a brief call. And with that, I guess we can open the floor for questions.
Thank you very much, Christian and Lorena, for that very nice overview. I think I'll open the floor for questions and comments now. As you can see, the tool is actually capturing all of the things that you are doing. There is some pre-information in the columns as you hover over it. And we are going to be having some videos as a resource when they are ready. But for the moment, we will share the recording of this meeting so it can help you. And again, if you feel like you're stuck, you can send us an email and we can provide support from where you're stuck from. Now I think the floor is open for questions and comments. Please raise your hand. I'll give you a chance to speak. I do not see any hands up for the moment. I think Chris and Lorena did a very good job that people can understand. Inusa, please.
Okay, thank you very much. Thank you, team, for this presentation. I've seen that there is a scheme for the OPV. What kind of OPV is that? Yeah, can I have an idea of it?
Christian, Lorena, do you want to respond to that?
Well, it just refers to all kind of open pollinated varieties that some of you might be working with. Although I explained we have tried to cover the different types of crops, the individual schemes, the hybrid scheme, the line scheme, the OPV scheme, they have to be somewhat generic, but they're asking for certain information, for certain family structures, for terminology, which is adapted to the specific breeding scheme. So every kind of open pollinated variety breeding program some of you might be working with is going in there. I'm not sure if this was the answer you were hoping for, but that's the answer I can give.
Yeah, so Inusa, it's a template where you can fill in all the steps that you follow within an OPV breeding scheme. So I invite you to try out the tool, and when you are selecting in the beginning, if you're working with an OPV, you select the OPV option, and then it will give you the breeding scheme sheet for the OPV.
Okay, thank you.
It's going to be very, very similar to what we have shown here. So we went for a line scheme, but the other schemes are, most of the individual sections are quite similar. For the OPV, for example, there's going to be some differences here where you describe the population structure because there's a little bit of different terminology. But most of it, especially in the OPV scheme, is very similar to what you have seen here.
Okay, thank you.
Janila, please.
Yeah, thanks, Dorcas. I mean, it's quite a detailed spreadsheet. Definitely, we may have some questions as we start filling into this spreadsheets. That said, just wanted to know for the ABR line breeding program, when we have a potential bee as it moves to the conversion program, CMS conversion, I mean, how is that captured here in this?
Christian, Lorena, do you want to respond to that?
Yep. So I understand this is part of a hybrid breeding program, right?
Correct. For a hybrid
Yep.
program, you have a B, and now when you move into the conversion program into a CMS line.
Yep. So for the hybrids, we have, well, we know that there might be different pools that you treat differently, that you treat individually. So if you choose the hybrid scheme, you have something like a rider at top here where you can choose between the different pools. Now, if hybrids are probably the most challenging to come up with a generalized template for, but you have, well, one hybrid where you can describe where you treat pool A and one where you treat pool B. And if you have to add some other information, well, maybe you put it in a new template. It's hard to make specific recommendations now without knowing the scheme. I would recommend give it a try, have a look at the different schemes. And again, if you run into problems, reach out. And if it turns out we have missed something very important for your specific case with a conversion step or conversion program as part of a hybrid program, we can still add that afterwards. But again, give it a try first, have a look at it, and then if there's problems, please let us know and reach out.
Thank you, Christian.
Okay. Yeah, thank you. Rosa?
Yes, hi everyone. Thank you for showing us and describing this tool in such detail. It's very useful. I think some of my question was partly answered previously, but Dorcas, since we had very recently discussed the forages program and how there is kind of a split in our case between the product development and the breeding methods and part of the program. So I was thinking, would you agree that I could try to fill this breeding scheme manager using open pollination and focusing on the breeding part of the program, and then treat the F1s, the apomictic F1s as clones, maybe, or what would you suggest?
Yeah, so Rosa, I think at the moment, the forages breeding scheme is still run as the hybrid because you still use the decampance tester. And in that, I would think you still fill this into the hybrid scheme. As Christian just mentioned, just try it out in the hybrid scheme. If you run into problems, you can reach out and we can support you from where you are stuck. But ideally, yeah, what the scheme is capturing, since even when you are selecting between the sexual and the apomix, you're still running through the different stages, and that's what the scheme is capturing. But yeah, when you get stuck for your specificity of your crop, please reach out and we can support you.
Okay, thank you.
Yeah.
So also all the different programs, all the different schemes, they have some specificities, but you see this is a line breeding program and you still can choose clone here. So usually the kind of descriptors or the characteristics that I assume will need to describe a clonal program or clonal structure within a hybrid breeding program, it should allow you to do that. But again, as Dorcas said, we are aware there's some specific cases, and I'm sure that these 4 relatively generic templates will work for probably 95% of the programs, but there are specific cases which we might not have covered good enough yet. So if you're running into one of these cases, again, please reach out. There's always the capacity to extend this tool a little bit if this is required.
Yeah, thanks. Balua?
Yes, okay, thanks. Thank you for this tool. I think we will need to try and come back with some question, maybe also some suggestion to improve. Because there are some terminologies we really need to maybe comment on that. Like when you move, you saw you got the seed after crossing, you move to F1 and you call it like a seed increase. So it can be confusing in breeding. So maybe like generation advancement, or so there are, or when you say old variety, I don't know if there is anywhere we can see what does it mean, because old, do we have a number of year? And so there are kind of such kind of question we need to, maybe we need to address. So my general question will be, do you expect like feedback so that you can still improving, or it's kind of final version? And also for hybrid, I think Janila commented a bit on it. We need to customize maybe one for like sorghum, millet. We are using CMS because it's quite different from maize. But we will try. If you use the maize schema to develop, this one we really need to customize for sorghum and millet, where we need to convert when you are your beeline. Another is N to see a summarized schema, kind of schematic schema, so that you can have all this information together. But because we used to do it with BPAT template, where you fill all the information, but at the end at the end it design it for you. I don't know if you think about it, if it's there or not. So yeah, but it's very good one. So thanks a lot and congratulations.
Thanks, Balwa. So I don't know the BPAT tool, and I'm not sure what you're referring to, but answering his first question, yes, please send us feedback. It's not a final tool. I mean, even PowerPoint and Word are not final tools, and they've been around for I don't know how many years. There's probably always going to be there's going to be a lot of options for improvement. If you're running into issues, if you have improvement suggestions or requests, please share them with us. And if what you just mentioned is one of them, again, maybe Dorcas, who has been around in some of the BPAT meetings, know what you mean. I don't know, but maybe it would be an option to add that. On the terminology, so if we look at something like the names that we use here, these are the names that you give your different stages. These are, I would say, program or maybe even pipeline specific. You can call them whatever you want. The terminology that we're using here in terms of crossing and screening, or the ones that we can choose here, are to some extent, especially those ones, they're aligned with the terminology that is used on the breeding portal. And on the breeding portal, there's a glossary with terminology that has been defined for the use within the CGIAR, because, you know, especially a couple of years ago, all of us were using different names for the same thing and communicating. It's on the breeding portal, and the terminology that you're using here in general is mostly aligned with that. Fixed, I would recommend first have a look at the glossary on the portal. If it's not explained there, if there's still some issues, again, this is probably one of the feedback points that you could share with us.
Yeah, thank you, Christian. I don't know, my internet is a bit unstable now. Can you hear me, Balua? Okay, so I wanted to add to what Christian said. You mentioned the BPAT tool. Soon, actually, the BPAT will be aligned, and they will be using this tool for the breeding scheme, so they will not be having the separate tool that you have been using now. The other reason is you mentioned that at the end of it, it gives you a flowchart of your breeding scheme. Actually, we are trying to avoid the flowcharts because we want the breeding teams to document their decisions, giving the actual numbers, that's the value stream. But yeah, we did have previously an option to create a flowchart at the end of adding in the breeding scheme, and that's something we can add to this template if that is something that is needed. For the moment, we have not activated that because we want the values to be documented within the breeding scheme. In terms of the terminology, for example, you mentioned all breeding material and varieties. Yeah, if you find that the definition is not included for a given column, please.
I think she's going to reconnect.
Oh,
Please.
I got lost, sorry. I don't know
Okay.
where I got lost, but I just came back.
Yeah, probably 30 seconds ago when you just started talking about the alignment of BPAT and this tool.
Okay. So I was saying we'll be aligned, and BPAT will not have a template for the breeding scheme, but they will need to adopt this one. And as Christian already mentioned, if you go through any of these columns and you feel like you do not understand any of the definition of the columns, or it's not adequate, please reach out and we can talk through that so that we can all understand what each column is means in this case. I will want to go now to Miguel and then to Gary. Miguel, please.
Yeah, thanks. Thanks to all for the presentation. Sorry, I missed the first 15 minutes, so maybe you already said it. But what will it be to actually have it all structured so you can use AlphaSim after we input all the data in the manager? Because that will be really helpful as a Christian. I mean, AlphaSim or whichever other breeding simulator, because that's not straightforward. So if this tool serves so we can actually then use it directly, it will be great. Even if it could be integrated in the tool and there will be a second step in which actually we get the efficiency of the program, that will be even better. I don't know if you're thinking of that or if it's already included, but I missed it at the beginning.
I can take that one actually. Just clarifying, like this is more like a documenting breeding scheme tool. So this is for breeders to have a clear understanding of what their breeding scheme looks like, and not just them, but also the people providing support and in terms of like optimizing steps of the breeding program and so forth. So this is more for the breeders to actually like outline their breeding programs, what are the numbers that they've been using at each stage of selection, and the different stages of selection on the breeding schemes. So this is what this tool is for. In terms of like, you can probably use this to design a simulation, but just like by the information that it provides. And yes, as a person that provides support and that carries on like a simulation with AlphaSim, I think this is quite helpful for me to actually like simulate the breeding program, but seamlessly transform this into R code for our for AlphaSim R. That will be quite the challenge, and it's not the objective of this tool, which is basically to outline the breeding schemes, not to simulate them.
Hey, if I can add something here, because I mean, filling this for all the pipelines is going to take me a lot of time, and it would be, let's say, I would be much more inclined to do it faster if there was something that it's not just outlining the breeding pipelines and the strategies, which as a breeder I already know. And I understand the point of having it clear and other people can actually see them perfectly fine. But I would say that I would do it faster if it was included in this part of the simulation, because that I would be really interested in. And then I would really devote the time to do this fast rather than, slowly.
Yeah, maybe Miguel, if I come in here, as Lorena mentioned, part of the information that we will use for simulating breeding programs will be captured in the breeding schemes. Now, this is not only for your understanding, because you already know the things that you are doing, but we are asking that you document those things for communication, for example, for your managers, your funders, and everyone else, so that we know, everyone knows, at least you know. But if you ask me now how many numbers Miguel is using and things like that, if I was to provide support, it would be difficult. So this is an open tool for all the stakeholders to have information and clearly understand where things stand at, what are the pipeline sizes, the numbers running through it. And this helps to make decisions, maybe not at the breeder's level, but maybe at a higher level, depending. And this also will help you, because we also have challenges, for example, when it comes to breeding teams, forecasting things like genotyping needs for the program in a year or something like that. When this is captured, this is going to be able to help you to forecast what needs you need, what other kind of support you need from the different teams that might be around to support you on this. So it's not just that you document your breeding scheme. It's going to be documented and being used to also ensure that the breeding activities or the breeding schemes are well aligned with the target product profiles. This will also be information that is needed in those discussions that we plan to follow up on this alignment for most breeding teams. So yes, Miguel, there is a lot of motivation from this, and this is actually information that we need quite urgently. That was going to be my last comment after the meeting.
I understand, Doctor, but this is a huge amount of work, and you know how overworked we are. So it seems to me like a bit of a lost opportunity if we don't include the simulation part in this.
There is a simulation part, because for the simulation, we need part of this information. But linking this directly to AlphaSimR, no, we are not at that step at the moment. So that's where we are at. And I acknowledge, of course, we all work in this sphere, and we are all a bit, we are all a bit with our hands full, but yeah. Sometimes when we document these things, and Joseph asked how often will this be updated? Joseph, this can be updated whenever you update your breeding scheme. So if you've not made changes to your breeding scheme, then you have not made changes. But if you update your breeding scheme, you'll need to document your new update, and that's why we have the timestamp here. I would like to go to Gary now, and then
I would just like to make a very quick comment, because I understand that, well, I would be happy if it was able to translate that into our code directly, but it massively underestimates the complexity of these simulations. And with these parameters, we are able to probably set up a decent simulation, but by no means does it cover everything that has to go into a simulation. And there's a lot of parameters that are missing, and there's a lot of parameters we probably wouldn't want to document here and ask you. So as much as I would like to have that, it's very unrealistic it's going to happen because of how complex these simulations are.
Gary,
can I jump
please?
in?
Yes, please.
Yeah. Unfortunately, I'm gonna kind of stay on the same point. So, I can imagine that linking them directly to an AlphaSim job would be difficult, and essentially requires a specific engagement with the QG team. But I sympathize with Miguel's point that it's unless this is somehow mandated that you don't get your funding if you don't do it. There's not a huge obvious value proposition for the breeders to invest time in this. It should be, it seems to me that it would be reasonable to link this to a deterministic modeler, the kind that I developed and that you, was incorporated into the toolbox. This is sort of the level of parameterization that you would need for spreadsheet modeling, and I find that sort of deterministic modeling really quite useful in terms of just looking at the relative potential impact of big changes. The other thing that we could consider, I wonder, as a next step would be including costs. So particularly, you've got so many specific activities quantified here that to add an approximate cost on, would be you'd have to think about how to do that, but it's quite doable. And then linking this into some type of tool that allows the breeder then to play with the parameters and look at different allocations of resources and impact on gains and costs would be, I think a lot of people would then be incentivized to do it. And any thoughts on that? I mean, obviously it's a big next step in development, but I think we have to think about how do we return some, well, how do we incentivize use for the breeders and provide direct value?
Yeah, thank you, Gary. Those are good comments and linked to Miguel's comments. I do think that, as you mentioned, yeah, well, we can explore methods of linking this to maybe a deterministic tool together with the costs. I think that's something we might need to work on in the next phase. Yeah, but for the current tool, I think it would be very helpful to us to have this information documented because, and I mentioned this because even when we have been mentioning about BPATs, when we have BPATs with the teams and things like that, you can find that there is always a disconnect between the breeding scheme and the target product profile. And we want this information documented so that as we go to the teams, we will be able to discuss and be able to align this first. And of course, yeah, optimizing the breeding schemes first. We are still providing support outside of this tool, of course, and outside of the breeding program, but would be good to provide a deterministic tool. So we can start discussions on that. But for the moment, we really need this information for the parts that we're finding challenging to help the breeders in optimizing. Michael?
Yeah, if I can just try and add my perspective on the value proposition of this, I think there's value in a number of different ways. One, starting with that, there's often a number of times in which a breeding program is asked either their breeding scheme in total or certain aspects of it, like what is your cycle time or what is your selection intensity, whether it's from BPAT or when it comes time to reporting. And I know that the Gates Foundation are asking for a lot of these indicators, and they're important to understand. And so we are working towards interlinking the various systems. So this one, breeding scheme manager, outputs from BioFlow, information that's in breeding portal, so that we can develop automated or at least semi-automated reports that extract those key indicators, and will do so in a much more much more streamlined way than has been done in the past. I mean, and even for this year, I mean, we've had, or in previous years, we've had a series of surveys. This year, we went through those deep dives as well. And so breeding teams are already spending a lot of time over and over and over again describing themselves, whereas the intention here is do it once, update it as soon as things change, and then it's there, and hopefully to try and actually make things more streamlined for the breeders. So that's one value proposition of this, if you like. Another is when it comes to optimizing breeding schemes and having and utilizing the support that is in Dorcas's team. We've really been missing something like this, because every time we go to have that conversation, I've been in these conversations where we spend the first day just trying to understand, well, what are you currently doing? What are the opportunities? And this is a way where in a much more harmonized way, we can straight away start running and with the information that's needed. And there are others as well, and and they've jumped out of my head now. I'm sorry, but there are a number of different ways in which we're planning for this to bring value to the breeding teams. But I do accept that it is a lot of work, Miguel, and we don't take this lightly.
Yeah, thanks, Michael. Someone else did have a hand up, but yeah, they went down before I could see who it was.
There is a question on the chat by Joseph. How often the information on the BSM needs to be updated? And I can jump in, like you might comment, Dorcas or Kristen as well. What I think is that if there's a significant change in your breeding pipeline, it should be documented on the BSM, right? So every time a significant change happens, basically.
Yeah, that's the answer, Lorena. So thank you. Anyone else has a question? Okay, Michael, do you want to make some comments about the breeding scheme manager and what the expectations are?
Yeah, sure. I mean, we've been grappling with this since the early days of excellence in breeding to try and have as streamlined a way as possible. And yes, again, I accept that it is still a job to fill this in, and in a harmonized way to capture what people are doing. Because, like I've just said earlier, I mean, it's the first step to trying to optimize a breeding scheme is to seeing what the current one is. So I think there is a lot of value here. I really hope that people do take the time. I've asked Dorcas how long she expects it would take people to fill this in. She thought, well, probably if they can set aside a few hours, they can get this done. So the expectation, Dorcas, your question was expectations. Yeah, I hope that for every breeding pipeline that breeders can fill this in, and then we can understand how things are tracking as well in terms of cycle time, selection intensities, etc. For those indicators that we're looking to link up and incorporate into those standardized reports, and that the Gates Foundation are asking for, and that presumably every breeding manager is going to be interested to see as well, and it sets up those breeding programs for support from Dorcas's team to dive in and look at details and work together on opportunities. So largely I'm just repeating myself, so I'll really stop it there. But great job to the team for getting this going, because like I said, it's this has been something I've been struggling with since the early days. So yeah, great job. Really glad to see that this is now up and running and ready to go, and I hope breeders dive into it and describe their programs here. And I'm really looking forward to seeing the details of these programs, because like I said, it's been hard to understand where the various programs are at, because they've typically not been described in a very harmonized way, and so it's hard to really understand where the programs are at for some of those components of the breeders' equation. So thanks, Dorcas, and well done to the team.
Yeah, thank you. And so just a final comment. I think we would be expecting, actually, apart from the delays that Christian mentioned, we expected to have the breeding schemes documented by the end of this year, so that we can be ready to use those to provide better support come early next year. And also, yeah, for the breeding leads here, crop leads, of course, you know that I've been sending out Excel sheets for KPIs and things like that. Yeah, we want to move away from that so we can extract information from what you have documented so far, as Michael mentioned. So the expectation as per now on implementing the tool is that most category 1, and category 1 is those pipelines that start from crossing and screening until on-farm verification, should be documented at least by early January 2025. We are available to provide support if you get stuck, if you have specialized breeding scheme and things like that. And we will be putting the videos as resources for you to be using. So those are our expectations. We would like to have all category 1 pipelines documented within the system by early January, and by January next year, given the delays that we had. Otherwise, our expectation was to have this done by the end of this year. So we hope the breeding teams can put some effort into this from their already overworked schedules. And yeah, I think I have new comments on the set before we close. Okay, so there is a comment from Gary saying donors do definitely need the program supported to be clearly described. And part of the stakeholders that we share information with is actually the donors in this case. And we want to streamline that process to also reduce the workload from the breeding teams when we go for different reports and things like this, so that we can have information as a central place. Thank you very much. And I'll stop here and thank everyone for joining, and do expect that the breeding teams can start inputting all category 1 pipelines. Thank you all.
Thank you all very much.
Thank you and bye-bye.
Thank you.
Thank
Thank you, Lorena.
Bye-bye.
Thank you, Christian. Yeah.
Thanks, bye.
Thank you and bye-bye.
Yeah.
Thanks, everyone. Bye.